Hello everyone, today we'll discuss differential evolution, one of the optimization algorithm that we will use for energy pricing to minimize mismatch between demand and supply, prices and price penalty. So let's start. First of all, I'm going to import numpy as np, and then I'm going to from sciencepy dot optimize import differential evolution. So first of all, we need to define the cost function, the objective function that we want to optimize, minimize, and we are defining price as x0 that will be picked from the bound domain prices that we'll define in the next step, and we can say that demand equals 200 minus 2 times price. If the price is too high, demand would be low. That's what it means. And supply would be, for example, fixed 140. Now I'm going to find the mismatch. Mismatch would be equal to absolute value of difference between demand and supply. And price penalty, you can define 10% of the price. So we want to return the sum of mismatch and price penalty. Of course, we want to minimize the mismatch between demand and supply and the price penalty, in the sense that if the price is too high, there should be penalty for that. So we want to minimize the mismatch plus price penalty. We can define bounds, that is the range of values for the price, and optimization algorithm will search these values from 20 to 100 price values that will minimize mismatch plus price penalty. Okay, now we can write the result as the function differential evolution cost comma bounds, and in the next step, which is the last step, we can say optimized price would be equal to result dot x, and we can also print minimum cost. What is minimum cost? The sum of mismatch and price penalty. So it's giving us optimized price is almost 30 and the minimum cost is 3. I think that's enough for today. Thank you very much. See you next time.